Alright guys, we are going to start this unit learning how to graph sine and cosine graphs, and we are actually going to start with the sine graph. And what I'm going to have you do is construct a table of values for sine so that we can plot a few points to discover the wave-like nature of this function. So as you guys know, the sine function, when looking on the unit circle, we look at the y values. So what I'm going to have you do at first is find the y values of certain angles found on our unit circle, okay? So what I want you to do is take the time to find the y values at 0, pi over 2 radians, pi, 3 pi over 2, and 2 pi radians. So at this time, pause the video and go ahead and find those. So once you have done that, you should have ended up with these values. Again, what you did is, looking at the unit circle, what you did was go look at the y values, and at 0, you had a y value at 0. At pi over 2, you had a y value at 1. At 0. At 3 pi over 2, -1. And returning back to 2 pi, you had a y value of 0. So those are where you got these values. So we're going to plot these points. We're going to let this be our x-axis, which represents our theta, our angles. And then this is going to be our f of x axis, which are the y values for sine. I'm going to use 2 blocks to represent every pi over 2 values. So we incrementally go up by pi over 2 until we reach 2 pi, and of course, you know, these go on forever. So 0, 0, right here at the origin. Pi over 2, up 1. I'm going to also let 2 blocks on the y-axis be now for 1. Pi over 2, pi 0. 3 pi over 2 drops to -1, and 2 pi ends up being at 0. So what you'll notice is this wave-like nature that we have of the unit circle. You kind of have to twist your paper sometimes to end up drawing these a little bit. Okay, now I've only drawn one wave. Okay, this needs to be understood that it goes on forever in both directions. That's a little OCD for me there. Okay, so if we keep drawing, you know, whatever direction, given an extension, we could see that this will keep going on forever, okay? But for now, I'm going to put a dashed line because I want you to know that this actually does keep going. But for now, what I want us to understand is I want to focus right now on this original parent function behavior of the first wave from 0 to 2 pi, okay? Because I want some terminology to be covered before we proceed. So one full wave has a length, what we will call a period length, okay? So from the beginning to right to the ending of our wave, we are going to call this the period, P-R-I-O-D, and the sine wave in this case has a period 2 pi because the wave repeats every 2 y units. Okay, now here, this distance right here from the midline is that, you know, symmetrical line that cuts the graph in half, okay? The distance from the midline to the top of the wave, or the midline to the bottom of the wave, that will be known as your amplitude, okay? So right here, this is known as amp for short, amplitude, the entire word. All right, so here I want you to notice that the graph goes up 1 unit from the midline to the top, and 1 unit down from the middle of the graph down, okay? That's known as our amplitude. Unit up and 1 down. Barely got it to fit. All right, so amplitude. So what I wrote there, notice the graph goes 1 unit up and 1 unit down from the midline of the graph, okay? So it continuously has 1 unit amplitude. So we're going to do this same thing now for the cosine graph, and we're going to call the cosine graph g of x in this case, and g of x equals cosine x. So what I want you to do is go ahead and create a table of values and the graph for cosine. Go ahead and create an x and y value table. Okay, so in this case we're going to have x and g of x, calling cosine g of x, and we'll go ahead and construct a coordinate plane for our graph. So we're ready to plot those points. So at this point in time, I want you to go ahead and use the same angle values you used for sine. Find those x values this time, plot them, and then unpause your video again. Okay, so if you're unpausing now, you are ready to check your values. All right, so for cosine, now what we're doing is examining the unit circle, and we're going to make our 1 revolution rotation, and now look at our x values. So hopefully you have chosen 1, 0, -1, 0, and back to 1. So hopefully here's what you filled out. You would have filled out what did I say, 1, 0, -1, 0, and 1. In the same manner you did above for sine, we're going to use every 2 squares to be pi over 2 units, and incrementally increase until 2 pi. And this time, let me see, I didn't label my axes. This will be 1 and -1. I just noticed that I never even labeled -1 up here. Alright, so 0, 1. So notice this time, unlike the sine, we didn't stay at the origin at the beginning of our wave. This time we had to start at the amplitude value at 1. Sine always starts on the midline. If you notice, if you look at this as a midline, okay, sine always starts on the midline axis. Notice you have 3 dots of sine on the midline, and then the amp values, 1 above and 1 below the midline. You're going to notice a difference with cosine. Cosine starts at the amp value, pi over 2, 0, pi, -1, 3 pi over 2, 0, and 2 pi, 1. And what I tell students is when you draw these 5 dots, I want you to notice it looks like an absolute value function. You know, like if I were to connect those dots to make a V, obviously it's not a V, but it has to be perfectly symmetrical. So please notice that always, okay? So what you're going to do is, since we know it's a wave like in nature, just like sine, I always start by making the waves, you know, the max and min values right here. It helps with drawing and connecting the dots. I do that first, and then I can just kind of twist and use my lack of drawing skills. All right, let's do this. There you go. I'm going to twist your paper a little bit. At least I do. Okay. Again, just like sine. Oh, that's just awful, and it bothers me. Okay. I'm doing my best here. Anyway, I'm going to have to let that go. Okay, so this, just like sine, notice I'm going to put an arrow saying that it goes on forever. And you can repeat let me extend this a little bit more. I know there's going to be another point here. It's kind of going up, across 2, down 2, then a down 2, and across 2. And you keep doing that nature. It will go on forever. And I'm going to use dashed lines for now. Where's that up to? It's going to go right here. Okay. So it goes on forever. So here's what I want you to notice, the difference with sine and cosine, okay? So here's our cosine graph, the first wave, okay? I'm only focusing on one period. That's not to say that's the entire graph, okay? The entire graph goes infinitely in both directions. But again, here's our midline, okay? Notice that the beginning of our wave did not start at the midline. It started at the amp value, okay? And this time we have 3 values that are not sitting on the midline. I always do 5 points, okay? Do 5 points. So with sine, let's do this again. You have 3 points, 1, 2, 3 sitting on the midline, 1 above and 1 below. By the way, if this was a reflected axis, a reflected sine graph, this point would be down here, this point would be up here, okay? But you always have 3 points sitting on your midline. Over here for cosine, you have 5 points as well. This time you have 2 points on your midline. And now you have 1, 2, 3 sitting at the max and min points, okay? So there's that. Again, same thing with sine. It has an amplitude of 1, okay? Notice again, it has a length of period 2 pi. So none of that has changed with respect to this graph either, okay? So this is an amplitude of 1 as well, the parent graph. And where is this? And from here all the way to here as well, you have a period length of 2 pi for the parent function. So those are the main 2 graphs we're focusing on today, our sine and cosine. And as you know, with all the functions you've learned in the past, transformations are going to occur. This graph is going to shift horizontally, shift vertically. It will stretch, compress. So we're going to analyze how those are going to happen. So here's what I would like you to do is, at this point, you're going to pause the graph, your notes again, and I'm going to want you to copy down this portion right here, and then we'll talk about it. So pause your video now, copy that down, and then we'll continue. Okay, so if you have unpaused by now, you have copied down the notes for this section right here. Here is the breakdown of these two. Okay, so sine and cosine, notice that I've introduced these little placeholders, so to speak, of letters A, B, C, and D that will represent numbers that are going to affect our parent function in some manner, okay? So A is going to be the coefficient of our trig function, whether it be sine or cosine. B is going to be the coefficient of our x, because if we were to distribute it, okay? So B is going to be the coefficient of our x, which x in this case is our angles, okay? The C is the value that you are adding or subtracting to your angle, and that will cause us to have a horizontal phase shift depending on that value. And d is that value on the outside of the function that we're adding or subtracting that will result in our vertical shift. And these two behave in the same nature that all the other functions have happened that have dealt with those values as far as transformation goes. All right, so when I ask you to find the amplitude of your sine or cosine graph that's been given, you are going to look for the a value. Like I said, that's going to be the coefficient of your sine. Because we're dealing with distance, amplitude is a measurement of distance, you will always find the absolute value of whatever that function, whatever that coefficient is. So if this was a -2, you would take the absolute value of -2, so our amplitude would be +2. If this was a 3, the amplitude would be the absolute value of 3, which would just be +3. I did put an asterisk up here by the word amplitude, and for a, in reference that I wanted you to take a note of something. Just like in other functions, if you had a negative coefficient, so if your coefficient of a is less than 0, that automatically means that your graph is going to reflect over the x-axis. So speaking of these, what happens is this point would be graphed here. This one can't reflect over the x-axis, it stays there. That one goes up here, this stays, and this goes down here. So your graph just flips over, okay? If you looked at the sine graph, that means this one will come down, stay, stay. This one will go up, stay. Again, it flips like that, okay? So that, look out for those negative values. And when you are looking to find the period, the length of that wave, of one wave in the given function, you are going to either use the units of 2 pi or 360, and the reason why we're using those values is because our original graphs are of length 2 pi, okay, or 360. I constructed these graphs in units of 2 pi, but please notice that you can use 2 pi or 360 degrees, okay? So the reason we're using 2 pi or 360 as reference is because that's the length of our original parent function of one wave. So whatever your b value is, that's going to be the coefficient of your angle. Take that 2 pi and divide it by that number, or if you're working in degrees, 360 and divide it by number. The answer to that simplified answer will be your period, your wavelength. To find out if your graph moves horizontally or vertically, you are going to look at this value for horizontal movement, and just like we've done in the past, you always do the opposite. So if this is a minus value, you're going to go to the right. If you are adding, you're going to the left. With a vertical shift, whatever that value is, you do exactly what it says. If it's positive, you go upwards, and if it's negative, you go downwards. Okay, so make a note here for yourself on horizontal, in parentheses. Always do the opposite, just in case you can't remember that from transformations in the past. I just also brought up 2 other characteristics of your function. Notice for both the sine and the cosine function, the domain values, which are all the x values used to graph your function, those are going to be all real numbers. Our graphs go infinitely in both directions, to the left and right. They're continuous, so we're using all x values. It is all real numbers, or in interval notation, we write it as -infinity to +infinity. Notice that your graph fluctuates and stays within the bounds of 1 and -1 and never goes past that in our parent function, so the range is trapped between -1 and 1 inclusively. So these are just the basics of our parent functions, and we're going to use this knowledge to be able to graph some other functions. So let's try it out, okay? So let's go try it out with this first function. So pause your graph at this time, and I want you to write this out and write this setup, and we'll walk through this together. All right, so here is our first graph, 3 sine 1/3 x. So let's start off with our amp value. Our amp value is going to be the coefficient of our sine. So we are going to take the absolute value of 3 In this case, it's going to be our 3. The period length is going to be, let's do 2 pi. You can do 2 pi or 360 in this case. I'm going to do 2 pi. All right, so 2 pi divided by our b value. Our b value is always going to be found to be the coefficient of our x. So the coefficient in front of our x is 1/3. So I'm going to put 1/3 right here. Okay? And 2 pi divided by 1/3 is 6 pi. If you want to do all the work, it's like saying 2 pi times the reciprocal of 1/3, which is 3/1, which is 6 pi. Okay? The reflection, that value is positive, so it's going to be none. And now let's talk about our phase shift. What you're going to do with phase shift, that means discovering whether or not it has moved to the right or to the left. That's what phase shift is talking about. Okay, I'm going to put this here. You're trying to figure out if it's going to the right or to the left. You're going to take what is right directly after our sine function. This is what you're always going to use, that quantity. And you are going to always set it equal to 0. And the reason why you're setting it equal to 0 is that our parent function, if you notice from before, our parent function, where do I have it? Here. Our parent function of, what are we doing, sine, started at 0. So that's why you're doing 0. Okay, so you're taking the junk after your sine and setting it equal to 0. My junk after sine, and I'm setting it equal to 0. And I'm going to solve for x. Now solving for x means I have to divide both sides by 1/3. Well, dividing both sides by 1/3 still gives me an x equals 0. So this graph is going to start at x equals 0 just like the last one did. Our ending point is going to be wherever you started, which in this case we started at 0, and you have to add the length to it, okay? So if I started at 0 and I know my period length is 2 pi, well, 0 plus 2 pi ended up at 2 pi. This one here, I'm going to start at 0, but this time my period length is not 2 pi, it's 6 pi. So you're going to, for end, I'm going to make a note here for you guys. I need you to take your start point, okay, plus whatever your period length is. That's what you're always going to do. And your start point comes from right here, okay? So my start point here is 0 in this case. My period length comes from over here, 6 pi. So my ending point is going to be at 6 pi. You remember we do 5 points. Here are 2 of them already. Okay? Vertical shift, nothing. Nothing's happening. There's no adding or subtracting any number over here to the right. So here you could just write any or none. And this just means, since there's no vertical shift, that just means your midline remained at the x-axis. Okay? At x-axis. It's not going to go up or down anywhere. Alright, so it's going to stay right here. So let's start. I know that my graph started at 0, so I'm going to put a 0 right here. That's x equals 0. Okay? I know my amp value is going to be a 3. And you remember with sine function, again, a reminder, your 3 points are going to be on the midline, and then you have 2 points that are going to be off the midline, okay? So that's why I knew that I'm starting right here at the midline, okay? Now I'm going all the way to 6 pi, so 6 pi is some distance out there. I'm randomly deciding to do this. Let's see, let's count by 1 pi. 1 pi, 2 pi, this will be 3 pi, 4, 5, 6. Okay, you can count by whatever. If you wanted to skip every 2 blocks and make that 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, you can do that. So you choose what you want to count by. Alright, so I know my starting point's at 0. I know my ending point has to be at 6 pi, starting and ending. And I know from my parent function I have to have 1, 2, 3 midline points, and then 1 top and bottom halfway between the midlines. See? It's halfway. Halfway is right here, halfway down. So use your symmetry. From here to here, halfway would be right here. And then halfway between here and here is going to be somewhere around here. And I'm going to go about right here. I'm randomly choosing an altitude, okay? And since this is my random altitude, the altitude of my functions are going to be a 3. So I'm going to put a 3 here and a -3 here. So there's my wave. And I'm going to connect my dots. I'm going to twist my paper here to make it easier. And you do the same. Okay? So there's that one wave. Now remember what I told you guys, these graphs go on forever. So when you guys are doing your assignment, I want you to give me at least 2 waves, okay? Don't give me any more than that. So you can either extend your wave to the left or to the right. I have more space on the right, so I'm going to extend it to the right. So let me extend my x-axis a little bit more. So this is, I'm going to put this arrow saying, okay, you're still going on. I'm going to keep going here, keep going, and it's, let's see, this is, I'm going to go, what was that? 1.5, so it's going to be 1.5 right here, and then right here, 1.5, it's kind of hard to see here, right here, and right here. So I'm going to connect my dots again, keep going, so then I have at least another wave drawn, and then I'm done. Okay, so that's all you have to do. Okay. Okay, so you're done with that graph. So there's the graph of y equals 3 sine 1/3 x. And I would like you to provide me 5 points, and always use the 5 points that that I gave you, that you first graphed. Okay, so in this case, the first graph point was 0, 0. So over here to the left, I'm going to put the points 0, 0. The next one was halfway between 0 and 3 pi. So in this case, it is going to be 1.5 pi. So I'm going to put 1.5 pi, comma, positive 3. Then 3 pi, comma, 0, which is that one. Halfway between 3.5 and 6 is 4.5, comma, -3. And the last 6 pi, comma, 0. And I want you to notice how these are all symmetrical as far as in the increments that it's increasing. So 1.5, another plus another 1.5 is 3, plus another 1.5 is 4.5, plus another 1.5 is 6. Okay, so notice those will increase equally, and then these fluctuate. Okay, all right, let's try number 2. Here we go, and the new graph we're going to do is going to be another sine graph. Y equals 4 sine of x plus 3 pi over 4. So again, I want you guys to do what we did up here and find all these characteristics, okay? So pause your graph right now, pause the video I mean, and do that. Okay, so at this time, hopefully this is what you have, or close to it. Remember, you guys are just starting, so don't beat yourself too much if you didn't get all these, okay? So the at value, again, we looked at the coefficient of our trig function. In this case, it's 4. Absolute value of 4 is 4. Our period length is going to be 2 pi, because basically, I guess I should show my work here. We take our 2 pi, and we divided it by our b. Our b value is right here in front of our x. In this case, it's a 1. And 2 pi divided by 1 is 2 pi. Reflection, there isn't any, because our coefficient remained positive. Our vertical shift, I kind of put it out of order, but our vertical shift, there isn't any, because again, there's no adding or subtracting of any number on this side, okay? If there was a vertical shift, you would see something like this, like a +5, and then you would tell me, oh, it's going up 5 or something like that. Or -3, you'd say it's going down 3. Alright, phase shift, like I've told you before, you take everything that is right after the sine function, set it equal to 0. It's always 0. For sine and cosine, you're always setting it equal to 0. And solve. Well, x plus 3 pi over 4 equals 0, so I have to subtract 3 pi over 4 on both sides. So my starting point is going to be at x equals negative 3 pi over 4. My ending, again, you always tell me where it starts and where it ends. Plus the period length. It started at negative 3 pi over 4, so take the start value, and you are going to add it to your period length. And in this case, our period length was 2 pi. Negative 3 pi over 4 plus 2 pi, get a common denominator. You guys can use calculators to speed up the process. If you want, you would write negative 3/4 plus 2 in the calculator, but just do the math fraction and get 5/4. But again, know how to do it by hand because it's important. This is like saying 2 over 1. The denominator's not the same, so multiply top and bottom by 4, and you're going to get 8 pi over 4. Negative 3 plus 8 is 5 pi over 4. Okay? Alright, so we know our graph will start at negative 3 pi over 4 and end at 5 pi over 4. Okay, so what you're going to do is construct your x and y axis and decide what you're going to count by. So let's do this together. If we're starting at negative 3/4 and ending at 5/4, okay, so negative 3/4 is down over here on this left side, okay? So let's count by 1/4, okay? So negative 1, negative 2, negative 3. So here's my negative 3/4. I know I'm starting way over here, and I'm having to end at 5/4, so I now have a dot right here, okay, at my midline. My midline is not changing because, again, there was no vertical shift. And I have to go to 5/4 to put my ending dot. So this is negative 1, 2, 3. So this is 0. So this is 1, 2, 3, 4, 5. So here's my ending point. 5 pi over 4. Alright, so I need, again, midline. Have 3 dots on my midline. Then I have 1 dot here and 1 dot down here. But I need my middle. So let me count how many blocks there are. There's 1, 2, 3, 4, 5, 6, 7, 8. So halfway would be a 4. 1, 2, 3, 4. So I'm going to put my dot right here. And I need 2 more dots to make 5. So halfway between these two, which are 4 squares, is going to be here. And I need to go up a certain altitude. Well, how high do I go? Well, my altitude, my amp value is a 4. So instead, 1, 2, 3, 4, that would be so tall. I'm gonna make my units, I'm gonna make this be a 4. Remember, you have control of making what your 4 is. So I'm gonna make 4 2 blocks. And 2 blocks. Okay, as long as you label it. So I'm gonna put, this is negative 4, so I'm gonna count by 2s, 2, 4, because, I could have put it up here, okay, and it would have just been a really tall graph, and that's fine too. So it's up to you. If you did that already, that's fine. And so again, let's do our little curved graphs. Oops, that went off. Okay, and there is our first period. Okay, again, extend it to this side or this side. And I already had one completed over here, so I'm just going to go ahead and show you the one I did. So here it is completed. Alright, and put your arrows at the back end and the front end, and I extended one right here. And again, I just counted 6, 7, 8, 9 fourths, 10, 11, 12, 13 fourths. My 5 points, again, were these right here. 1, 2, 3, 4, 5. I always use the first wave, those points. Okay? Notice how they're going up incrementally by 2 fourths. Negative 3 plus 2 is negative 1. Negative 1 plus 2 is 1. 1 plus 2 is 3. 3 plus 2 is 5. So it went up by 2 fourths. And it fluctuated. Okay? Alright. Let's go to the next one. All right, here's the next one. On the next two, I'm just going to actually just walk you guys through it. And if you don't want to attempt it on your own, which I highly encourage, just pause the function and then copy down this problem and look away from the screen and try and work this out. But anyway, here's the cosine graph, and you're going to notice that the same approach is going to be used here. Amp is the coefficient of cosine 1/2. Our period, in this case, notice this problem was given to you with an angle given in degrees. So we're going to do 360 divided by our b, and our b is the x value, which is right here, the coefficient of our x, which in this case is a 3. And that's going to turn out to be 120. No reflection again. This is still positive. Our phase shift, I'm going to use PS for phase shift. Take your entire trig function junk right here, and I want you to set it equal to 0. Again, same thing as sine. Add 150 to both sides, and then I divide it by 3. So right here, this is my starting value. I'm going to put my first dot at 50. Okay? Where am I going to put my second dot? The ending point. Again, take your starting point plus your period, 170. So again, you decide what you want to count on the x-axis by, okay? And this is totally up to you. In this case, what I did was I counted by 20s. So 20, 40, 60, 80, 100, and I counted out another 100 to get to 200, and I literally just placed my dots, okay? Notice midline is so important. So I know for cosine, my midline points, I'm going to have 2 dots on the midline, and then 3 dots off of the midline. So here are 2 dots right here. So, sorry, I'm going to start with the 50, my bad. So my 50, 20, 40, 60, so 50 is right here. And you remember, you always start at the amp value. My amp value is 1/2. So I just went up a certain distance. You decide how far up or down you want to go, okay? I like to keep my graphs a little smaller. So I said 2 blocks would be 1/2. So I put a positive 1/2 there, 2 blocks down, negative 1/2. So I put a dot here, and my ending had to be right over here at 170. So 20, 40, 50, 60, 20, 40, 60, 80, 100, 120, 140, 160, 180, so 170 is right in halfway. So I put my dot there. Then I put halfway. If you want to find halfway, there was 1, 2, 3, 4, 5 squares, and then this was a little 1/2 and 1/2. So I went 2.5 squares. So use your symmetry, and I put another dot here, dot, dot, and so this was my wave right here. See, that was my wave right there. Again, look, it looks like a V if you take away the wave. See, my 3 dots, 1, 2, 3, and then here's the other part, 1, 2, 3. Again, 2 dots, 1, 2, 1 here, 1 there, 1 down here. And then I just extended it, okay? So this is the wave right here. Let me do that. There's the wave, and then I extended it on that side, okay? Or you can extend it on this side, I don't care. So I don't care what you do. Just put your arrows at the end. Again, I put those points, okay, which was these. 2, 3, 4, 5. Notice they're increasing by 30s. 30, 30, 30, okay? And then fluctuates. Okay, so pause it here to take a look at this and make sure you understand it. Okay, copy those notes down. And we have one more graph. All right, so let's go down here to this one. This one, I made sure to do one that had a vertical shift. And this is our last one. I know it's been a long lesson. So again, pause it right now so that you can copy down this problem and at least figure out all the characteristics, and then we'll go from there. Okay, so right here is our amp value. It's going to be R4, take the absolute value. The period is 2 pi divided by your b. Well, 2 pi divided by 3, you're just going to leave it there. I can't simplify any further. No reflection because it's positive. I'm going to take everything that comes right after my trig function. I'm not going to include that because that's vertical shift, by the way. I just take this part right here, set it equal to 0, and do my math. So subtract by pi over 4 on both sides. So 3x equals negative pi over 4. And then I'm going to multiply both sides by 1/3, or divide by 3, whatever you want to say. So if I'm going to divide by 3 on both sides, I need to multiply by the reciprocal. So the reciprocal of 3 is 1/3. So if I multiply by 1/3 on both sides, notice that 1/3 of 3, well, 3 divided by 3 cancels and it becomes 8x. And when I multiply this by 1/3, negative pi times 1 is negative pi, and 4 times 3 is 12. So this here is going to be my starting point at negative pi over 12. Ending, again, nothing has changed. Take your starting point, negative pi over 12, plus the period, which you found out over here, 2 pi over 3. Add those to get 7 pi over 12s. Again, you're getting common denominators. Again, you can use the calculator. Negative 1 over 12 plus 2/3. Treat pi as a variable. You'll get 7/12, and then just bring the pi down. The vertical shift is this number that is hanging out here all by itself. Since it's adding, you do exactly what it says to do. That means it's going to go up 2 units. So notice what's going to happen. Your midline in all the problems that we've done has always been right here at 0. But now they're saying, hey, your midline is going up 2 units, so bam, that's what you did. Okay, so this is your new x-axis, for lack of better words, okay? So here is going to be 2, all right? All right, so here's what's going to happen. Since we're up 2, you're going to have, where is it? Where am I going? Oh, here's my point. I'm counting by 12ths, okay? So negative pi over 12. Here's negative pi over 12. Again, I made one block. Random choice. I decided one block is going to be negative pi over 12. And I have to go up 2. So you remember your x-axis is no longer here. I'm not going to go up 2 here. Here's my new x-axis at negative pi over 12. You can't see what I'm saying. So I'm going to go up 2 units. So I'm going to go 1, 2. Okay? Because my amp value has to be 4. Okay? So 1, 2, 3, 4. I did this wrong. Sorry, you're going to go up 2 because of your vertical shift, but your altitude is going to be 4 because of your amp value. And then my ending is 7 pi over 12, so I'm counting by 1/12, so it's going to be 1, 2, 3, 4, 5, 6, 7/12. Remember, I'm starting here instead because this is my new x-axis, and I need to go up 4 for my amp value. So here and here, find the halfway point. So halfway point is right here. But remember, the distances have to be the same, so I know that distance is going to be 4 down right here. So I put my dot here. And then halfway between that and that, notice it's 4 blocks. So halfway is 2. And I know my midline always has 2 dots with my cosine graph. So I had 2 dots up here, 1 dot here, and 2 sitting on the midline. So I just connect my dots. I didn't have space to give another period, but you understand how to do it. And as usual, got those from the 5 dots, the initial graph. 1, 2, 3, 4, 5. Okay, so instead of using your midline at 0, you use your midline here. Okay, so imagine this being your new x-axis. And that's it. So make sure you copy these down as your notes as well. Hope that helps, and of course we'll see you next class and answer all the questions you may have. But please, please, please try your homework, okay? And good luck.